Now what we're doing today is circles. Now for the most part, circles are actually quite nice. They're quite easy to work with. Because by definition, a circle is the set of all points equidistant from a fixed point called the center. So, and we're given an equation for a circle by this here. X minus h squared plus y minus k squared is equal to r squared, where r is greater than 0. Because we're talking about a distance with r, because it is the radius, it has to be positive, so greater than 0. And we've done this before. We've talked about these before, because we've done them a little bit in Algebra 2. Geometry, we've talked about circles. And one thing to pay attention to, especially when given the formula for an equation of a circle, not so much the last one, but whatever's inside the parentheses is kind of opposite of what we think. Because if we're told that it's x plus 3, it's really negative 3 for the center. If it's x minus 3, the x value is 3. Just based off the equation. So there's different forms that we'll look at. One of them, the most easiest in my opinion, is if we want to write the standard form of the equation of a circle given the center and radius. Because no matter what the setup is, for us to be able to graph it or find the equation, we need the center and radius. Those are the two pieces of information we need. Now, since this one already gave us the center of the circle, negative 4, 6, all we need to do is plug in the center and radius into the equation. So the x value of the center is negative 4. The y value of the center is 6. And the radius is 2. Now at this point here, we do need to simplify. So negative negative makes plus. So we have x plus 4 squared plus y minus 6 squared is equal to, well, 2 squared is 4. And that is the standard form of the equation of this circle. And that's it. That's all we have to do. Now on the homework, it will ask you to graph this here. In graphing a circle, the first thing we need to do is find the center. And we go over to negative 4, 6. We find that point. And on the computer, it does have an option to click for circles. You'll click it, find the center first. The next thing is to find the radius. Now, with this here, having a radius of 2 is nice. Because all that means is I need to pick a direction, up, down, left, right, and go over 2 spots and make a point. And for the program, that's all you'll need to do, because it will make the circle for it. It'll generate it out, and you're done. If we were doing this by hand, we would go right 2. We would go left 2. We would go up 2. We would go down 2, and just connect all those points. We have the circle. And that's it. Now, not every radius will be a nice number. There can be some that are not. When I say nice, whole numbers, integers, positive numbers. We can have fractions. We can have radicals. Any of those are possible for the radius. And the computer version of this will give you the option to plot a point. So you just have to add it to the x or y value of the center and plot that point. Questions on this here? Now the next type that we can have is we want to find the equation of a circle given the endpoints of the diameter. But with a circle, if I'm given 2 endpoints of the diameter, one of them is at negative 1, 0, the other is at 3, 4, When we connect them together, we get the diameter. Well, we know what half the diameter is. Half of the diameter is the radius. And one key piece of information about the diameter is that the diameter will always pass through the center. And the center is going to be the exact midpoint, because the diameter is equal to 2 times the radius, twice the radius's length, goes to the center. The center has to be in the middle, obviously, because they call it the center. So there's 2 equations we need. One of them is midpoint. And the other is the distance formula. We need these 2 formulas here. The midpoint is going to be used to find the center, and the distance formula is going to be used to find the radius. Now, it doesn't matter which one we find first, but normally it's going to be more helpful to find the center first. Because if I know what the center is, I can use the distance formula from the center to one of the diameter points to find the radius. We don't have to, because we could use the distance formula to go from endpoint to endpoint. But whatever that length is, I have to divide it by 2 to get what the radius is. Because if we use the 2 diameter points, we're finding the diameter, not the radius. So if we find the midpoint first, well, our x values are -1 plus 3 over 2, and our y values are 0 plus 4. Now at this point here, you could plug, well, we need the 2, this into the calculator. We can do -1 plus 3 divided by 2 in the calculator. Because if we did it by hand, we would have 2 over 2, which simplifies to 1. For y, 0 plus 4 is 4. And 4 over 2 is 2. So the center for this circle is at the point 1, 2. And we could use that. We can say x minus 1 squared plus y minus 2 squared. And that's all we have so far, because we still don't know what the radius is. Now we still need to find the distance, or in our case, the radius. Now I would use one of our 2 points, either -1, 0 and 1, 2, or 3, 4 and 1, 2. I'm just going to use -1, 0. Because we have -1 minus 1 squared plus 2 minus 0 squared. And again, at this point here, you can plug this whole thing into the calculator. The calculator will do it for you. We don't necessarily have to write this out. Now, -1 minus 1 is -2 squared plus 2 squared. Well, -2 squared is 4. 2 squared is 4. And 4 plus 4 gives us the square root of 8. Which, if we wanted to simplify it, I wouldn't. This is going to be 2 square root of 2. If we did this in the calculator. Now, the reason I say that is because here, we're just trying to find what? Standard form of the equation of the circle, yes? So, I could use 2 squared root of 2. Yeah, 2 squared root of 2 squared, we can multiply that out. I don't know about y'all, but doing 2 squared root of 2 in your head is a little challenging, yes? But what is 2 square root of 2 the same as? Square root of 8, yes? What's the square root of 8 squared? It is 8. So there wasn't a whole lot of reason to simplify it. especially if we're plugging it back in. Now, if we were graphing it, knowing that it's 2 square root of 2 or really square root of 8 isn't going to make a whole big difference, especially on the graph. If we were doing this by hand, this one would not be one that I would have you graph. Because plotting 2 square root of 2 distance for x or y is not a nice amount. But I will show you how to do this still. There is on the ALEKS, the ALEKS program, there is a key where you guys can access square roots, powers, fractions, all of those there. There's going to be one that doesn't look like a plus sign. I didn't draw it well. It's going to look like a grid or a point, and it's going to let you plot a point or multiple points. And when you can click that, it'll pull it up, and you can select the point, say 1, 2. And you say plot, and it'll plot the point. Okay. Now, we need to go a set distance to get the radius. Now, for us, well, 2 square root of 2, we can add it to the x or y, which would give us 1 plus 2 square root of 2, comma 2, or the square root of 8. You should be able to do either one of these here. And it'll plot that point out there for you. It'll plot it for you. And again, at this point here, you would click the circle button to create the circle. Click the center first, and then drag it over there, and it'll generate the entire circle based off those 2 points. Does that make sense? So when the radius isn't nice, 2 square root of 2 is not nice, when it's fractional. Any of these here, use this plot point and essentially pick one of them, up, down, left, right, to get there. Now, we technically did have a 0.34, which would have worked well too. You could have used it also, so gone from center to 3, 4, or 0, -1. Questions on this here? And there's other ones with this, given the circle and radius or given the center and a point, we're still doing the same thing. Because if we're given center and a point, we just find the distance and we have the radius. Any questions on any of this so far? Now this one here, an equation of a circle written in standard form, or written in this form, is called general form of the equation of a circle. We're going to need to get it back into standard form to be able to find the center and radius, or to be able to graph it. Which means we need to take it from this form here back into our x minus h squared plus y minus k squared is equal to r squared. Which means we're going to have to complete the square. We're going to have to use completing the square to get there. Now, for the most part, what I've seen, especially with the homework and what we're doing here, we're not going to make this as challenging as it possibly could be. And what I mean by that is, if we look at the first one, here, what is the number in front of x and y? Well, 1, yes? If we look at the other example, here, the numbers in front of x and y are both 2. X squared and y squared are both 2. And if we look at the third example, they are both 10. These are some of the easier ones, I would consider easier ones that we're dealing with. And what I mean by easier is that if this was, say, 20x squared and 10y squared, we'd have to work it a little different. It's not that it's any harder, we just have to take them individually. But we'll look at this one here first. What we need to do first is two things. One, we need to get x and y by x's and y's together. So I always rewrite this first. X squared plus 10x plus blank minus blank plus y squared. Well, plus blank, yeah. Plus blank plus y squared minus 6y plus blank plus 25. Now we will eventually need to move the 25 to the other side, but we can leave it there for now. Because our goal, again, is to get this into x minus h squared plus y minus k squared is equal to r squared. We need to rewrite both of these as a perfect square trinomial so that we can rewrite both of them as a set of parentheses squared. Now to do that, we need to find the value of c. c is equal to b over 2 squared. Now with doing this, there's two ways kind of that we go about it. One of them is, if we're lucky enough that x and y don't have a number in front of them, we can add this c value to both sides of the equation. If not, we'll have to factor it out and then add it and subtract it from the same side. Because when we add it to both sides, we're not changing anything to it. We're adding the same thing to both sides, so increasing it by the same amount. If we add and subtract the same number from one side, if I add a to it and subtract a from it, well, a minus a is 0. We haven't added anything. So we either add it to both sides or add it and subtract it from the same side. Those are the two ways to go about it. If both x squared and y squared are 1, we can just add it to both sides and it's going to be easier to work with. So for this here, we can look at x first. C is equal to b over 2 squared. Well, our value of b in this case is 10. And 10 divided by 2 is 5. And 5 squared is 25. So we'd add it to the left side of the equation, and we will add it to the right side of the equation. We'll have to do the same thing with y. But y's b value this time is -6. And -6 divided by 2 is -3. And -3 squared is 9. So we're going to add 9 to both sides. Any questions on anything we've done so far? Yep. I'll have to do that in a minute. Now, on the right-hand side, we can add 25 and 9 together and get 34. We'll have to subtract the 25 over. That's what I was thinking about for a second. We can do it in the next step and be done with it there. Inside both of these parentheses, we will have the x and y by themselves. Now, the number that goes with it will be whatever the number that we had for finding the c value before we squared it with the sign. So with x, when we divided by 2, we got 5. So inside these parentheses, it will be plus 5. And this is kind of a shortcut way to get there, because if we think of x squared plus 10x plus 25, what times itself is 25? 5. Since it's plus, the signs are the same, match sign in the middle term, it'd be positive 5. Or with y, it is -3. So here we would have -3, because 3 squared is 9. Since the middle term is -6, it has to be minus. Questions on this here? Last but not least, we'll need to subtract 25 from both sides, telling us that x plus 5 squared plus y minus 3 squared is equal to 9. Now our center, x and y values are going to come from inside the parentheses. Since it's x plus 5, the x value of the center is negative 5. Since it's y minus 3, the y value is 3. Is again, if we look back at the formula, it's x minus h squared plus y minus k squared is equal to the radius squared. Well, the only way I can turn x minus h into x plus 5 is if the value of h is negative. Y minus 3, we already have the y minus, like with y minus k, so k is just 3. We have that change of signs. Now, lastly is the radius. Well, we know what the radius squared is. The radius squared is 9. So if we take the square root of it, the square root of 9 is 3. And that's it. And if they wanted us to graph this, all we need to do is use the circle feature, start at the center, negative 5, 3, and go 3 units up, down, left, or right. We just have to pick one, and it'll do it for us. Questions on this here? We're ready for the next one. Find the center and radius given this equation. Now this here and the ones I've seen for the homework assignment have been very nice in that one, the x squared and y squared for both of these here are the exact same. They're both 2. Also, every other number in the equation is even. It's divisible by that number. So what we can do, and this really only works if x squared and y squared both have the same number in front of them, is we can divide the entire equation by that amount. We can divide the whole thing by said amount. And really, if it's a circle, we have to do this. It's actually only going to work if it is a circle doing this here. I'm realizing that now, because otherwise it's going to end up being ellipses or a hyperbola, because we need the number in front of both of the parentheses to be 1, and the only way that works out is if the numbers in front of x squared and y squared are the exact same. So with any of these here, we're going to end up dividing everything by said amount. Now what that'll give us is x squared plus y squared minus 16x plus 6y plus 45 is equal to 0. Now we're going to do 2 things in the next step. I really should have done this on the last one, but one of them is going to get our x's together and y's together and move the constant term to the other side. I really should have done that on the last one, but really we want the x's together, the y's together, and the constant numbers to move to the other side. Because again, in the general form, in the standard form of a circle, the x's and y's parentheses are on the same side, our constant terms are on the other. Now at this point here, we do need to make our perfect square trinomials. And the first one we can look at is x. So c is equal to negative 16 over 2 squared. Well, negative 16 over 2 is negative 8. And negative 8 squared is 64. And we will add it to both sides. we have to do the same for y. Now y's b term is 6, so we'll have 6 over 2 squared. 6 divided by 2 is 3, and 3 squared is 9. So we'll add 9 to both sides. Now again, the number that goes inside the parentheses with x is the number that we had before we squared it. So -8. So we have x minus 8 squared. And with y, the number inside the parentheses before we squared it was +3. So we have y plus 3 squared equals so we need to add these together. -45 plus 64 plus 9 is 28. Yep. Any questions on how we got to this equation here? Now the center is going to be the point what? 8 comma -3. Because x minus h, so instead of x minus 8, we're talking about h being 8, and y plus 3, it comes out as -3. Radius. Well, the radius squared is 28. So we're looking at the radius being the square root of 28, which I believe is 2 square root of 7. So the radius is 2 square root of 7. And if it were asking us to graph it like I've already shown earlier, we would first plot the center and then add 2 square root of 7 to either the x or y value of the center and have it plot that and connect the two together. Questions on this here? Questions on anything we've done so far? We good with all of these here? Do we need to see another example of one of these? Because the only other type that could come up on the homework is that they give you the center and they tell you that a point on the circle is 1020. Find the center of the circle, or not find the center. Find the standard equation of the circle and graph it is the only other one that's going to come up. But the standard equation of the circle we already have most of it because we'd have x minus 7 squared plus y minus 4 squared. The only thing we don't have is the radius. That's the only thing we're missing. And really to find the radius, we're just using the distance formula with the center and the point on the circle. Odds are this is not going to be a nice number. I'm saying that because I just picked 2 random points to use this with. And again, our distance formula is our x values being subtracted and squared plus the y values being subtracted and squared. And again, at this point here, we could plug this into the graphing calculator, either calculator, and it'd do it for us. 10 minus 7 squared. 10 minus 7 is going to be 3 squared. 20 minus 4 squared is going to be 16 squared. I do know that 3 squared is 9. 16 squared is 256. So we're looking at the square root of 265. Is indeed the square root of 265. That's as simplified as it gets. Luckily for us, when we square the square root of 265, we get 265. So that does work out nicely. But that's really it. It's not that those are any harder. We just have to find the radius using the distance formula, and that's it. Any other questions on any of this here? So that's it for circles.